Okay, everyone, let's graph some absolute value functions. We haven't done that in a long time, and you may have actually done it last year in IM1 class, but here's a quick refresher on graphing absolute values. So as you can see here, guys, I got typical absolute value. See those vertical bars right there? Now remember, the absolute value of any number is always going to result in the positive version of it, right? So in other words, well, anyways, let's just learn by doing again. Now, how do you set it up again, guys, is please remember what always is going to work really well, even though you're going to learn some cool little shortcuts and tricks. Make a little table, okay? So as you can see here, I'm going to make a little table here. XY table, T table. And see if this sounds familiar. I'm going to look right inside my absolute value, and I'm going to ask myself, what makes it 0? Well, of course, 3 minus 3 is 0. Guess what? That's going to go right in the middle of my table. I'm going to pick a couple numbers bigger, a couple numbers smaller, and I'm going to be able to graph this within a minute or less now. So let's start by plugging in the 5 here. Okay. So I'm going to put in that 5 right there. And here's what I get. 2, absolute value, 5 minus 3, minus 4. Now, just like any parentheses, guys, we got to do the absolute value first. 5 minus 3 is 2. When I do this absolute value on the 2, I get a positive 2 times 2 minus 4. 4 minus 4 is 0. Now, one thing about absolute value is if you have the vertex, which is basically what that middle number is, and you have everything spaced out evenly, you can use symmetry. So if you plug in 1, guys, trust me, you will get 0. All right, let's start with the next number, the 4. So we're going to plug a 4 right in there. So here's what we got now. 2, absolute value, 4 minus 3, minus 4. Now 4 minus 3 is 1. The absolute value of that 1 is simply 1 times 2 minus 4. 2 minus 4 is negative 2. By symmetry, 2 is also negative 2. You could also plug in 2 to double check, but we should have a nice symmetric graph when we're done here, guys. Finally, let's do the 3, also known as a vertex. So when I plug in 3, we already know 3 minus 3 is 0. And 2 times 0 is simply 0. Minus 4 is negative 4. And now all I have to do is graph my function. 5 is 0. 4 is negative 2. 3 is negative 4. 2 is negative 2. 1 is 0. If I connect those points, notice you get what we call a V shape. This is what an absolute value will always look like, guys. It will look like a V. But that's all there is to graphing absolute values. Pause the video if you need to. Okay, guys. Why don't you give this one a try? You could pause the video and just give it a try. Okay, let's see how you did. Did you make a table to start out with? Did you look right inside the absolute value and ask yourself, what makes it 0? Negative 3 makes it 0, correct? So negative 3 goes right in the middle of your table. Did you just count up and down 2 numbers in each direction? Keep them in order like I did. See how I have negative 1, 2, 3, 4, and negative 5? Because then you can use symmetry, okay? If you don't have them evenly spaced in order, guys, you can't use symmetry. All right, let's start by plugging in, of course, the negative 1. So here's what we're going to have when we plug in that negative 1. 3 and negative 1 is 2. The absolute value of that 2 is a positive 2. I'm now going to times it by negative 3 and add 1. Guys, notice I'm doing the multiply by negative 3 after the absolute value is done, because you basically treat absolute values like parentheses, okay? So anyways, continue on. Negative 3 times 2 is negative 6, plus 1 is negative 5. By symmetry, negative 5 is also negative 5. All right, let's go on to the next number, negative 2. So let's plug in that -2. -2 and 3 is 1. Absolute value of 1 is still 1. Now I'm finally timesing by -3 and adding the 1. -3 plus 1 is -2. By symmetry, -4 is -2. Now, only thing left is my vertex, -3. To save a little time, do you agree? -3 plus 3 is 0. After all, we figured that out already. Times -3 is still 0. Plus 1 is 1. I'm ready to graph. Here we go. -1 is -5. -2 is -2. -3 is +1. -4 is -2. Finally, -5 is -5. Notice we get the V shape again, guys. And I think basically I'll stop the video there. I have a couple more graphs ready to go, but they all follow the same strategy and pattern. You start by making the table, guys. You figure out what makes it 0, and so on. So hopefully you understand this video, and you'll watch it again if you need to. Take good notes. But before I conclude my video, guys, I just want to point out, did you notice that this V right here is opening down? Why is that? Why would it be opening down? Well, there's a negative in front, right? A negative is going to make it open down. That's something you ought to remember. Contrast that to the first one we did. Notice this V here is opening up, right? This V is opening up. Why would it open up? Because notice the 2 in front is positive. So positive absolute value, guys, are V's that open up. Negative absolute values, the V's are always going to open down. That's another good thing to remember, okay, guys? So that concludes my video on reviewing graphing of absolute value functions. See you in class.